Welcome back to another particles video. In this video, we will be making the particle ice. Now, I asked you after the last video to think about how will ice behave? And there's a number of different things that you could have said, but here's what we're going to do. Ice itself is going to be a particle that actually doesn't do anything. But after a certain amount of time, what does ice do? It's actually going to melt into water. This is going to be our first example of a particle where the class that we make, when we make the ice class, it's not just going to be the one line class we've been doing for all of these ones before. We're actually going to have to add something in there. And we'll talk about why and what we're going to add when we get there. To start, as always, let's open up Particles Program and let's go ahead and go through our process of adding a new particle. We always start at the top here, so adding on a constant, I'm going to add public static final int ice equals 4. Once we've got that, we need to add a button for it on the screen, so I'm going to add it to my array of names. So I'm going to do names bracket ice equals ice. And then once I do that, I need to make sure I actually make my array 1 longer. Right now I have a 5th thing in here. It needs to be 5 long. I need to make it so that I can click on the screen and actually add ice if I have the ice button selected. So let's add an if statement in here. If particle type equals ice, we're going to say grid row call equals new ice. And of course, this is not going to work right now because I don't know what ice is. So let's go ahead and make the ice class. So I'm going to go over here. Let's duplicate one of these. It doesn't actually matter which one. I'm going to duplicate sand, and I'm going to call this ice. Now we're going to start this off in the same way, which is I'd still have to change this where it says sand here to all caps ice so that it matches the constant that's in Particles Program. I should probably also change the color. Let's change yellow to color.white. Here's the special thing with ice, is that we just talked about ice's behavior is that it's going to melt. Now, when will ice melt? That's kind of up to us, how long it's going to take to melt. But would you agree that actually after some certain amount of time, ice melts into water? Don't I then need to be able to know or track how long ice has kind of been alive or been on the screen? So that's actually what we're going to do here. For the first time, this ice class is going to have a private instance variable. Ice is going to keep track of how long it's been around, or what we're going to do is we're going to call it the age of this ice particle. So I'm going to up here type private int age. We've added a private instance variable. Here's the constructor. What's the job of the constructor? It's to initialize my private instance variables. Now it's really important, again, we haven't really talked about what this super means, and we're not really going to talk about it until the next unit. But one thing to know is that the super line is actually the line that needs to go first in the constructor. So when I initialize age, I'm going to do it below this line. And to start, when I first create a new ice particle, I think we should probably set its age to 0. There's probably 2 things now that I want to be able to do with an ice particle. When an ice particle exists on the screen, there needs to be a method in this class that allows me to make the ice older, right? Otherwise, it just starts with an age that's 0 and then it never gets older. And since I'm using that age to track when it's going to melt, if it never gets older, it never melts. Kind of a problem. So let's make this method. Public void, I'm going to call it increment age. And remember, increment is just that fancy word for go up by 1. So what's actually going to be the code in here is I'm going to do age plus plus. Not all that crazy. Now let's do one more method, because one other thing I need to be able to tell for an ice particle is this ice particle melted or not? So let's do this. Public Boolean is melted. And it's up to us. We can just choose a value that we think works. So I'm going to do here, let's return age is greater than 1000. And I'm doing a little Boolean Zen there, right? When would this be true is when the age is bigger than 1,000. And what does this 1,000 mean? That's actually kind of how many times this particular ice particle is going to end up getting stepped in our program. Now, this 1,000 is something that I can play around with. If I feel like the ice lasts too long, I can make this number smaller. If I want it to be ice for longer before it turns into water, I can make this number bigger. It's kind of up to me. So let's compile this. And then let's go in my particles program, and I'm going to scroll down to the step method. So I have to add another layer to this. Let's do else if particle.getType equals ice. Then I'm actually going to want to do a few things in here. If I step an ice particle, the first thing that should happen is, doesn't its age now kind of go up by one? It's been around for one more step, right? So I want to do particle dot increment age. You would expect this to work, but it actually doesn't. And you can see that there's an error here. And if I scroll my mouse over that, this actually says undeclared method increment age. Now, you might be thinking to yourself, what do you mean undeclared method? I just declared it, right? Here it is in the ice class. There is one really important thing with writing methods in particular particles. If I look up here, here's the variable particle that I'm trying to increment its age. What type is particle? Particle is a capital P particle. Now, does every single type of particle have a method called increment age? No, this is actually a method that is specific to ice particles, which means that I need Java to acknowledge that this particle is specifically an ice particle. And even though it looks like I'm kind of doing that in this if statement here, this is kind of the acknowledgement or the check for us as programmers. This isn't actually the check that Java will be able to tell. And here's how you can actually tell Java that this particle is an ice particle. I'm going to do it like this. Ice, and let's call it ice particle, equals ice particle. And this line looks a little bit weird. Where have we seen something like this before is actually when we're typecasting. So it kind of looks like I'm typecasting this particle into an ice particle, which is not actually really what's happening. What you're really doing here is having Java acknowledge, yes, particle is a particle, but specifically what type of particle is it? It's actually ice. And the ice particle has its own specific behavior that I want to be able to use. And now I called this ice particle, so instead of particle here, I need to call it ice particle. And now this will work. And now looking at this, it's not like you can just make anything into an ice particle. Like I can't say ice, the number 42. That won't work. I can't just typecast anything into anything I want. This actually only works because particle is an ice particle, and I know that because I've checked it up here. All right, and again, this line looks a little funky. You'll get used to doing this if you're trying to use methods that you wrote in a particular particle class. You need to write a line similar to this to get Java to acknowledge, yes, this is this specific type of particle. I promise I know what I'm talking about. All right, so we've incremented its age. Isn't there a chance that after incrementing this particular ice particle's age that it could actually be melted? And how do I check that? I can say if ice particle dot is melted, then what do I want to do? Well, it's not ice anymore, right? Doesn't this ice particle actually turn into a new water particle? So I'm going to do grid row call equals new water. And let's actually take a look at what this looks like. I'm going to compile this, and let's run it. And let's take a look at our ice. If you put ice on the screen, look, there it's ice. And after a little bit, what happens? It actually melts off into water. This is a pretty cool behavior. I think this one's actually really fun. And why were we able to achieve this? What did we have to do this is, again, ice had this kind of special behavior in its class where it keeps track of its age. It's pretty normal that you might want to write a particle that has kind of specific things about that particle, maybe some private instance variable I need to track or some specific special methods for just that particle. And ice is an example of one of those particles. We're going to have probably one, maybe two more particles videos. So in the next one, we're going to take a look at one other type of particle that's going to be kind of cool. It's a particle that actually won't have a button to click on the screen. You can actually only get this particle by making two other particles on the screen interact with each other. So I'll see you in the next video where we talk about that special type of particle.